This is an example of what the system looks like when you're running tags. At this point, we've run about 1,000 tags at 10 per second. We've had 3 failures, all on encoder 3. So that gives us a chance to maybe move the antenna a little bit or tweak the power, do something to try to bring that in. But in any case, it's 3 failures out of 1,000, which gives us a yield of 99.7%. That's encoding at 10 per second. This window here gives us feedback. It's a running display of everything that comes off of the real-time components of the system. Everything good is colored in green. Anything bad is colored in red. And here's one of those 3 encode fails on encoder 3. Informational text is colored in black. The side of the application gives you an easy place to set things up. And there's a place up here to stop and start the rewind system. This is a grid view. This is a way to keep track of all the text that comes out of the real-time system. This column here corresponds to the gap. In fact, let's go get closer to the end. If this is 50A, we can find the read for 50A. It's 50A. The TID ends up in 98C1. 98C1. And this EPC 50A was encoded to 58C1 by encoder 1, which was read at gap 50A. And we can see that if we come down here, look for the T1 at 50A, 98C1 got the EPC ending in 50A. Even though this is a reel-to-reel machine, we're not running reels right now. We're running a test strip made from about 64 1 3/8 inch repeat tags. The advantage of running a test strip is that all the TIDs are known. There are no bad spaces on the web. And when a problem comes up in debug, we know where to look. Now, you don't normally run this way in the field. However, some people with the GlueLogix rewind system will set up a test like this for a new batch of inlays in order to see how they survive the nip. I want to give a short overview of how the system operates at a sort of a micro level. Everything runs off of the gap sensor. When the gap sensor fires, as it will when this gap goes through the sensor, the system will read a tag here, and it should read this D8 98D1 at that time. So to read that, figure out what encoder it's supposed to go to, and then schedule that encode operation for one of the 3 downstream antennas. Now, a few gaps ago, we had a tag read that was allocated to encoder 1 And that tag was the one that ends in 98D4, which we see over here about to enter encoder 1. We're going to advance the web one spot, which means we're going to turn on the stepper until the gap sensor fires, and then we're going to stop. When we stop, the system is going to read D89, D8D1, but it's also going to encode D89, 8D4. We're going to get a good message for this tag. We're going to get a read message for the new tag, and we're going to see encoder 1 light up blue when it encodes the tag. So here we go. I'm working the mouse with my left hand now. Blue light on the encoder. We got a good encode message on 98D4, and we got the expected read message on 98D1. So as you're setting your systems up, you can do something like this and step through individual tags one at a time and watch the blue lights. On the next cycle, we should get a blue on 2. And on the next cycle, a blue on 3. Back to 1. Back to 2. And back to 3. Now, the trick is to do this at 5 per second, 10 per second, 15 per second, 20 per second. We're about halfway there.